Hey everyone. For this video we're going to stay in our solar system, but we're going to talk specifically about the interaction between the sun and the Earth and our moon. And so when we look up in the night sky, we often see the moon, and sometimes it's fully lit up, right? It's a bright white color, and sometimes it's not lit up at all, and we can barely see it. And most of the time it's somewhere in between. So we're going to look at what causes those shapes of the moon to occur. And so just like in our solar system walk, we need to shrink our objects down to a more manageable size. So for this demonstration, we're going to be using a basketball for the size of Earth and a tennis ball for the size of our moon. And that's roughly the right proportion. But if the Earth was the size of a basketball, the moon tennis ball would be about 25 feet away, and the sun, which we're just going to use a flashlight for, would be a couple of miles away. So that part is not to scale, but this will at least give us an idea of how those interactions work and how we can demonstrate the phases of the moon and eclipses also using a model like this. So let's go over to our model. So here's our moon. And you can see that there's a clear dividing line between the light side and the dark side. And so the moon, of course, circles the Earth sort of in this way. It doesn't circle right between the sun and the Earth most of the time. It does sometimes, and we'll talk about what that creates. But so let's think about what we're looking at if we're looking at the moon from the Earth. So we're standing, somewhere right here, roughly, right, pointing towards the sun. And so let's say the moon is here. So if we're standing here and we're looking at the moon, almost all of what we see of the moon is going to be dark. So that's when we have a new moon, which is the term for when we can't really see the moon, it's dark. So that's when we are seeing the dark side of the moon, if we were able to see it at all. So reverse that, if we are still on Earth, of course, but we're looking at the moon when it's over here, that's when it's going to be a full moon. So the full face of the moon, as far as we can see, is also being lit by the sun. Now, of course, there's the in-between steps. So if the moon is over here, and we are still on Earth, so we're standing here, we're seeing half the moon lit and half of it dark. And then same thing if the moon is on this side. If it gets a little more complicated if the moon is not on either one side or right in front. And so if the moon is, say, here in relation to the sun and the Earth, then we are going to see a lot of it dark, but a little bit of it still light. So this is when we get a crescent moon. So that's when there's less than half of it being lit. And then when the moon is here, so this is maybe a little easier to visualize. If we're standing on the Earth here, we can see the moon, it's mostly lit. So there's still a spot over here that we can see, but it's not lit up by the sun. So this is when the moon is called, it's in what's called the gibbous phase, and that's when it is more than half full. So first remember that when the moon is like this, when the moon is in between the Earth and the sun, that's when we can't really see the moon because it's dark, right? The lit up side is facing towards the sun and away from us. But there's another setup, another positioning where the moon is totally dark, and that's when it's actually in the Earth's shadow. So you can see here that the Earth does have a shadow. You can see it in the background here. It's hard to see in space because there's nothing in back really. But you can see when the moon is orbiting the Earth and it passes into the shadow, then it also gets dark. And this is what we call a lunar eclipse. So a lunar eclipse is when the Earth is directly in between the sun and the moon. And when we see this happen, the moon gets a really nice, really pretty red color. And that's because of how the light sort of interacts with the Earth as it's going towards the moon. So it's usually not totally dark, but it's a really interesting color. The other type of eclipse is called a solar eclipse, and that happens when the moon here is right in between the sun and the Earth. And so you might say, well, why is that different from a new moon, right? Because the new moon is when we're on the Earth, the moon's in between, and we can see sort of the dark half of the moon. Well, in this case, the moon is actually directly in between. And so we can see that the moon is casting its shadow on the Earth. So if you're standing here on the Earth, then you are in the moon's shadow. And this is what happens when we get a solar eclipse. Now this happens every couple of years or so, somewhere on the Earth. In one place on the Earth it happens much less. So here in the United States we had one a few years ago, and we're going to have another one in about 4 years, I believe. So it's pretty rare, but it's really spectacular. So those are our eclipses. So this is the solar eclipse when the moon is in between. This is the lunar eclipse when the Earth is in between and it's sort of blocking the sunlight from reaching the moon. All right, so that was pretty cool, and it worked really well. Definitely something you can try at home if you have a light source like a flashlight and two spherical objects of different sizes. So we had our tennis ball moon and our basketball Earth, and we observed that no matter what, unless an eclipse was happening, that half of each object, half of the moon and half of the Earth, were lit up and the other half were not. So keep that in mind next time you go outside and observe the moon. You'll know that half of it actually is lit, and it's really just our perspective from here on Earth that seems to change the shape. So our next solar eclipse is in 2023, visible here from North America. And then our next total solar eclipse is actually just the following year, 2024. So if you want to get ready for those, you can check out my Safe Sun Observer video, and that will show you how you can make an object that will let you observe the sun safely so you don't have to look directly at it. Because even during an eclipse, the sun is extremely bright and would damage our eyes if we looked at it. So I hope you enjoyed that. I hope you give it a shot at home. And thanks for tuning in. I'll see you next time.